Our story begins in a vast cosmic cloud, a swirling nebula of gas and dust. Imagine a time before our sun, before our planet, before life itself. This nebula, a cold and silent giant, drifted through the cosmos. Gravity, the architect of the cosmos, began to work its magic. The scattered particles within the nebula, drawn together by their mutual attraction, began to clump together. As the nebula contracted, it began to spin faster and faster, like a figure skater drawing in their arms. A star, our sun, was beginning to ignite at the heart of this maelstrom. As the sun ignited, it bathed the surrounding nebula in light and heat. The rotating nebula, flattened by its own spin, formed a disk of material around the newborn sun. This protoplanetary disk, a cosmic pancake of gas and dust, would become the cradle of our solar system. Within this disk, the seeds of planets, including our own Earth, were beginning to sprout. The sun's gravity pulled in the majority of the material, forming the star we know today. However, a small fraction of the nebula's original material remained in the swirling disk. Within this disk, particles began to collide and stick together. Dust grains clumped together to form larger and larger aggregates. This division of materials would have a profound impact on the types of planets that would form. Within the protoplanetary disk, a cosmic dance of gravity was underway. The dust grains, now clumped into larger aggregates called planetesimals, continued to collide and grow. These planetesimals, ranging in size from meters to kilometers, zipped through the disk, their paths influenced by the gravity of their neighbors. Over millions of years, these collisions sculpted the planetesimals into larger and larger bodies. The largest of these bodies, called protoplanets, grew to dominate their regions of the disk. In the inner, hotter region of the disk, rocky planetesimals coalesced to form the terrestrial planets: Mercury, Venus, Earth, and Mars. Further out beyond the frost line, the icy planetesimals grew much larger, forming the gas giants: Jupiter, Saturn, Uranus, and Neptune. The early Earth, a protoplanet still under construction, was a hot and violent place. Constant bombardment by planetesimals and the decay of radioactive elements in its interior generated immense heat. This heat melted the young Earth, turning it into a churning ball of molten rock. Within this molten mass, a process called differentiation began. The denser materials, primarily iron and nickel, sank towards the center of the Earth, forming its core. The lighter, silicate-rich materials rose to the surface, forming the Earth's mantle. As the Earth cooled, the outermost layer of the mantle solidified, forming the Earth's crust. This layered structure, with its solid iron core, molten outer core, viscous mantle, and thin crust, is a defining characteristic of our planet. Section 5. A giant impact, the birth of our moon. The early solar system was a chaotic and violent place, with collisions between protoplanets a common occurrence. A Mars-sized protoplanet named Theia collided with the young Earth in a colossal impact. The energy released in this collision was unimaginable, instantly melting Theia and a significant portion of the Earth's mantle. Debris from this impact was blasted into orbit around the Earth, forming a ring of molten rock and vaporized material. Over time, this debris coalesced under its own gravity, forming the Moon. The Moon, born from the fiery chaos of this ancient impact, would forever be linked to the Earth, its gravitational pull shaping our tides and its gentle light illuminating our nights. Section 6. A tumultuous youth, the Hadean Earth. The early Earth, still reeling from the giant impact that formed the Moon, entered a period known as the Hadean Eon. The early Earth, still reeling from the giant impact that formed the Moon, entered a period known as the Hadean Eon. The early Earth, still reeling from the giant impact that formed the Moon, entered a period known as the Hadean Eon. The early Earth, still reeling from the giant impact that formed the Moon, entered a period known as the Hadean Eon. The early Earth, still reeling from the giant impact that formed the Moon, entered a period known as the Hadean Eon. The early Earth, still reeling from the giant impact that formed the Moon, entered a period known as the Hadean Eon. Section 7. From fire to water. The atmosphere and oceans emerge. As the Earth cooled, the relentless volcanic eruptions that characterized the Hadean Eon began to subside. The molten surface solidified, forming the first continents. Water vapor released from the Earth's interior by volcanic outgassing condensed in the cooler atmosphere, forming clouds. Rain, torrential and unrelenting, fell upon the cooling Earth, filling the low-lying basins and forming the first oceans. The oceans, initially acidic due to dissolved volcanic gases, gradually became more alkaline as they interacted with rocks on the Earth's surface. This process, known as chemical weathering, removed carbon dioxide from the atmosphere, further cooling the planet and paving the way for the emergence of life. The stage was set for the next critical step in Earth's evolution, the emergence of life. Section 8. Life's first spark, the Archean Eon. The Archean Eon, spanning from 4 billion to 2.5 billion years ago, marks a pivotal chapter in Earth's history, the emergence of life. In the primordial oceans, in environments far different from those we know today, life arose from the chemical soup of the early Earth. The exact details of how life arose remain a mystery, but scientists believe that it originated in hydrothermal vents, underwater geysers that spew hot, mineral-rich water from the Earth's interior. The first life forms were single-celled microorganisms, simple prokaryotes that lacked a nucleus or other membrane-bound organelles. These early life forms were chemosynthetic, meaning they derived energy from chemical reactions rather than sunlight. The Archean Eon saw the diversification of early life into 2 of the 3 domains of life that exist today, bacteria and archaea. Section 9. The Great Oxidation Event, a breath of fresh air. For billions of years, life on Earth existed in the absence of free oxygen. However, around 2.4 billion years ago, a dramatic shift occurred, the Great Oxidation Event. The stage for this event was set by the evolution of photosynthesis, a process by which organisms could harness energy from sunlight to convert carbon dioxide and water into sugars, releasing oxygen as a byproduct. Cyanobacteria, a type of photosynthetic bacteria, evolved the ability to perform oxygenic photosynthesis, releasing free oxygen into the environment. Initially, the oxygen produced by these cyanobacteria reacted with dissolved iron in the oceans, forming iron oxide, which precipitated out of solution, forming vast banded iron formations. However, as the supply of dissolved iron dwindled, oxygen began to accumulate in the atmosphere. The rise of oxygen in the atmosphere had a profound impact on life on Earth, paving the way for the evolution of more complex, oxygen-breathing life forms. Section 10. Shaping the landscape, continents, and plate tectonics. While life was evolving and diversifying in the oceans, the Earth's surface was also undergoing dramatic transformations. The Earth's crust, broken into massive plates, was on the move, driven by the convection currents in the mantle below. This process, known as plate tectonics, has shaped and reshaped Earth's surface for billions of years. As the Earth's tectonic plates collided, they pushed up mountain ranges, creating the Himalayas, the Andes, and the Alps. When plates pulled apart, they formed rift valleys and new ocean basins. Plate tectonics has played a crucial role in shaping Earth's climate and the distribution of life on our planet. Section 11. A planet transformed life's enduring legacy. From its humble beginnings as a swirling cloud of gas and dust, Earth has undergone a remarkable transformation. From the fiery chaos of the Hadean Eon to the emergence of life in the Archean, from the Great Oxidation Event to the shaping of continents by plate tectonics, Earth's story is one of constant change. The Phanerozoic Eon, spanning the last 540 million years, has witnessed an explosion of life in all its diversity. From the Cambrian explosion to the reign of the dinosaurs to the rise of mammals and ultimately humans, life has shaped and been shaped by the Earth's ever-changing environment. Today, Earth stands as a testament to the enduring power of life. Our planet, once a barren and hostile world, is now teeming with life in all its forms, from the smallest microorganisms to the largest whales. It is our duty to protect and cherish this planet, our only home for generations to come.